Now I have the pleasure to introduce Dr. Henrik Jernvall, who is working at the Karolinska University Hospital in Stockholm, Sweden. You have seen with Mehdi's slides that inhaled gases, everything fluorine, is important in the carbon footprint produced by the anesthesiologist. So we need to reduce or refuse them. We'll ask you a different question on that. How to reduce the consumption of our gases?
Thank you very much. Yes, I can argue that we don't need to reduce the use, but we need to reduce the waste, because the most that we buy, we actually throw directly out in the sink. So what we use, we should continue to use, but we should use everything that we buy instead of throwing most of it out. So I will focus my talk on closed circuit anesthesia, and mostly actual medical benefits, because if you don't enforce or describe the medical benefits, you will never get people to use it. So first, some definitions. Low flow anesthesia is traditionally when you have a fresh gas flow less than the minute of ventilation. And that is a very high definition, of course. So most people nowadays say that fresh gas flow less than 1 liter per minute is low flow. But I'm going to talk about metabolic flow. And metabolic flow, or closed circuit anesthesia, is where you have a fresh gas flow equal to the oxygen consumption. And that is, in a normal patient, 200 milliliters per minute of 100% oxygen. Nothing else added to the circuit. And so nothing is added and nothing is released. And only oxygen is added and carbon dioxide is removed by the absorber. So you need to add enough oxygen to meet the metabolic needs of the patient, and you need to remove carbon dioxide. That's all there is to it. And since this is very simple, it was described and this is the only thing that we focus on now, the metabolic flow and 200 milliliters of oxygen. So this was described in 1924 by Waters, and he built a circuit, and he actually described it in detail, just like we know it today. So he said that it has economic benefits. So 1 gallon of nitrous oxide that he was using at the time should suffice indefinitely. And I argue the same, that if you have sevoflurane, it would suffice indefinitely, almost. But let's talk a little bit more about that later. And also convenience, because you have no waste. He was, of course, concerned with ether and explosion risks and stuff like that. But we are concerned with the environmental footprint, and we're also concerned with the worker environment and so on. And finally, the welfare of the patient. So there is no heat loss or less heat loss. There's the moisture is not lost, and there is only, I would argue, benefits, with one exception, which I will come to. So here are the indications and benefits. You see the economical and environmental. They are, self-evident, and the other ones are very real also. So we only have medical and physiological benefits. I see when a patient gets septic. I see when a patient gets malignant hypothermia. I see when the tube is leaking. Lots of things that we say sometimes is a problem, but I would argue it's an asset. You also have a recipe for anesthesia. If you teach a resident how to do anesthesia, they're very confused. You have flows, you have vaporizer settings, you have everything. Here's a very simple recipe. There are a contraindication, and that is if you need to eliminate anything by ventilation. Most commonly carbon monoxide, but of course anesthetic gas. If you use closed circuit anesthesia, the patient will not wake up. So you need to have high flow or increased flow when you want to wake the patient up. And also, I want to say that there is no risk for hypoxia. There is absolutely no risk for hypoxia. There is no difference whatsoever what the patient receives. So assuming, of course, standard monitoring, which we all have in all anesthesia throughout the world. And also, I want to say compound A is of no concern. That could be a lecture on its own, but it's been more than 1 million sevoflurane, 1,000 million, so 1 billion sevoflurane anesthesia, and there has been shown no kidney side effects from this. And the global potential, so this is just pure physics. What wavelengths they absorb and so on. And you see that desflurane is a high global warming potential, GWP, versus sevoflurane. And this is pure math again. Given sevoflurane needs 6%, and sevoflurane only around 2%. And you can see that the carbon dioxide equivalent is huge if you use desflurane as a relatively high flow. And the question is, does this matter? Well, we all agree that the car traffic matters. We try to reduce our car traffic. So if you put this into perspective, if you have 8 hours at work and you use desflurane at 2 liters per minute, desflurane at 0.2 liters per minute, sevoflurane, sevoflurane, sevoflurane at decreasing flows. And we see how far can you go with a car during your 8 hours at work. So if you use desflurane at 2 liters per minute, you can go to Cape Town, South Africa from Paris. You can take your car and drive it all the way to Cape Town. If you use desflurane at 0.2 liters, you can go all the way to Berlin and beyond, to the border of Poland. If you instead use sevoflurane, 2 liters, that is a high flow or relatively high flow, you can come to London from Paris. If you use sevoflurane at 1 liter per minute, which we in Sweden, Stockholm would consider a relatively high flow, you can go to Le Mans. And if you go sevoflurane 0.2 liters, which we use routinely in Stockholm, you can only go from a southern suburb to the airport. Not that you would fly, of course, but, well, in theory, you can do that. So my conclusion is use sevoflurane at a fresh gas flow of 0.2 liters per minute with 100% oxygen. And you will reduce your carbon print, you will reduce your cost, you will increase the patient's safety, and the teaching environment will improve also. Just benefits. But don't try to wake the patient up. When you want to wake the patient up, you have to go to high flow. Thank you.
Thank you very much, Henrik. Very interesting to travel like this with sevoflurane. Let's be more precise on the wording. When I learned anesthesiology, we use the term low flow, high flow. You changed the definition, so explain us again. What is low flow, what is high flow, and what is CCA, closed circuit anesthesia?
Yes, there are no definition of high flow and low flow because they are arbitrarily and they tend to move down as machines, monitoring, everything evolve. There is one strict definition, and that is closed circuit anesthesia. Closed circuit anesthesia or metabolic flow is when you release nothing to the atmosphere and you only add the metabolic need of oxygen. As I said, we in Sweden, in Stockholm, we say 0.6 liters is low flow. And I know in France you have a little bit higher, and you still call it low flow. And if you want to have a definition, I have to give you that anything below the minute ventilation is low flow. Okay. But there is really no definition, so you really have to be aware of what you're talking about when you say low flow.
Again, precision about monitoring. What do you mean by monitoring? Is it pulse ox?
Yeah. So in any anesthesia, anywhere where you use a circular system, you need to monitor the inspiratory, oxygen, and carbon dioxide, and also expiratory. And you also need to have a pulse oximeter. You have that in all anesthesias in almost all the world now, actually. So you just need standard monitoring like with any machine. And that's basically what there is to it. So the risk of hypoxia using low flow is exactly the same risk as using any flow, because there is always a risk that you have not figured out the needs of the patient. There's always a risk that you have a leakage in the system. There is always a risk that there is some other malfunction. So you always need monitoring, also when you do closed circuit anesthesia.
Yeah, I have a question, Henrik, because the American Society of Anesthesiologists recommend to use sevoflurane at 2 liters per minute. So
yes.
Why is it like this?
Yeah.
And many countries follow the ASA recommendation. So what do you suggest?
That is a function from compound A. And compound A is a substance. It's nephrotoxic in high doses, released by the absorber in conjunction with sevoflurane. And there's 2 papers in '97, one from Eger and one from Karash, I believe, and both of them measuring small amounts of micro traces from kidneys, not measuring creatinine, not measuring anything like that. And Eger says it has a nephrotoxic effect, and Karash negates that. And since then, it's been debated. And in 2001, there was a paper in Drugs, just saying that the bottom line is that compound A is not an issue. And since then, we, as I said, we had 1,000 million, and there has been shown no nephrotoxic effects. And it's a problem because we can never prove that something is safe. You cannot prove that something is safe, but as close as we have come, compound A is of no issue, and we don't consider it. But it is a problem. It is a problem, and I don't know how to solve that.
So FDA should change their
Yes.
regulation if USA
Yes.
move to sustainability. And I have another question, because I started to implement your protocol in my hospital because I heard your talk at the last ESA meeting in June. And it's very hard to convince, nurses are not hard to convince, but other doctors that there is no risk of hypoxia.
Yep.
So how do you manage this?
Well, because we are taught, and we are taught from the textbooks, and we know everything about diffusion hypoxia. We know everything about nitrous oxide, and that cyanosis is not a sign, and so on and so on. But nowadays, we have 100% monitoring. There is no risk of hypoxia, and that's my single most solid statement, and it's the one that gets the most questions. But again, there is no risk for hypoxia. You can use it for sensitive patients, you can use it for pediatrics, for pregnant, for thoracic. There is no risk for hypoxia. Thank you.
For the closed circuit, you said that we have to be below the alveolar ventilation. So do you calculate it for every patient, or do you take the cutoff of 200 for all the patients?
Yes, I take 200 for all the patients, and then I immediately notice, because of the monitoring, if I have a patient that is requiring more oxygen, I get an indication. How septic is this patient? Is he big? If he's big, I might start higher from the beginning. But the optimal case is where the bellows, if you have a bellows system, is not going all the way up to the top. And you always have a closed circuit, and you can monitoring. I can do recruitment on the patient. I can recruit lung volume and see how many milliliters of lung volume I have recruited. So it's only benefits.
And for monitoring, if you have one thing to see, it's oxygen expiratory or inspiratory?
Inspiratory, because we don't want to go below 30. Like in any anesthesia, like in any closed circuit anesthesia, you don't want to go below, well, air basically, but 30% we have as a alarm cutoff.
Okay.
Yep.
And for pediatric patients, how do you, how much oxygen do you put?
Yeah, most machines are limited to 0.2 or 200 milliliters. So we go for that. And then we have an open system, which is suboptimal. But in theory, and the manufacturer, they are into veterinary medicine. And the machines nowadays are very exact. But to answer your question, go as low as you can. And with pediatrics, 200 milliliters in a pediatric patient is extremely high flow. So you're on the safe side.
Well, a lot of questions. I have a tricky one. Do
Oh.
you use Desfluran?
Oh, well, we also have the tricky doctors that are not so easy to convince. But actually now I have, well, I shouldn't take the credit, but the word has spread, and we will now begin the process of actually ending Desfluran only in very strict. But as I said, if you use this protocol, you will wake up, the time for emergence is similar between sevoflurane and Desfluran. And it is. I know it is. I've seen it. I've done it.
You explained us before the session that you have you are building a huge hospital in Stockholm.
Yes. Wow.
Did you integrate all the things we can do to scavenge gases and to decrease all the consumption of
yes,
gases?
it's environmental friendly with both heatings and electricity, ventilation, and all aspects.
So what you mean, you turn off the lights when you
yeah,
when you leave
supposedly. We have some technical problems, but no, it's very focused on that. And one of the things is that we still use nitrous oxide for different reasons, but it's destructed. Given the hope that we will do closed circuit anesthesia, a case for 8 hours will only be the equivalent of taking the car between two suburbs. And we are humans, so we do have some sort of footprint, but don't go to South Africa. Even though South Africa is a nice country, don't go there by car, and don't go there every day.
Okay. Thank you very much, Henrik, for this talk.